with 90-degree angles. So because it's a type of parallelogram, anything that we knew that applied to a parallelogram, those 6 theorems are going to still apply to our rectangle. Okay? So let's go ahead and draw a rectangle here. I'm going to just eyeball it.
You want to use the lines on your paper there to help you?
Okay, so a couple things that I heard that were mentioned were opposite sides are congruent or parallel. So I'm going to mark that this one is congruent to this one. If you want those colored pencils, you can take those out. If you want to just use your pencil too, that's okay. This side is congruent to this side. So they're parallel, they're never going to touch. Opposite sides are congruent. Are opposite angles congruent? Is this bottom angle going to be congruent to this angle? Yeah. Do consecutive angles add up to 180? What's 90 plus 90? 180, yep. Okay. Our new theorem that is going to come to us is that when we have a rectangle, I'm going to draw one more just so I can color code it a little bit. Call that rectangle A, B, C, D. Our new rectangles is that the diagonals are I was going to draw in a diagonal.
And way back to 6-1 when we talked about diagonals.
What 2 points am I going to connect?
A and C. Or B and B.
Good. A to C and D to B. Those are going to be congruent to each other. So A is going to be the exact same length as DB. Because the diagonals are all congruent to each other, that creates kind of an interesting thing with our angles. So I'm going to use one color for all of these angles because we're going to have 4 inside angles that are congruent. So at angle D here, this inside angle right here that just goes to that diagonal is going to be congruent to this inside angle here. And that's congruent to this one. And 4 of those angles, because those are going to be congruent triangles. I know I didn't do a very good job drawing my picture, so my triangles don't look congruent. But all 4 of those are going to be congruent angles. They're all the same measure. And then the same thing happens with the other angles that are made. So this other angle at D right here is going to be the same as this side. Same as this one and this one. So when we have those diagonals in, it creates congruent angles with those diagonals as well, because the diagonals are congruent to each other. We're going to use that a little bit as we do our practice. Alright, ready for your first example? We're going to do 2 examples. One example is kind of going to be bigger than the other one. So here we go with our first example. We're going to draw a rectangle. because today is all about rectangles. You're going to get real good at drawing them. And we're going to have G, H, J, and K. We are going to draw in the diagonal, so you're going to connect H to K and G to J. However, I'm going to use a ruler because I didn't do a good job last time. That's a little bit better. Alright, we're going to do some sentence starters, and then we'll do the sentence, like, you'll have to finish the sentence. It's going to be the type of problems we're dealing with today, is creating true sentences based on our diagram here. Okay, so for our first sentence starter, it's if GK equals 6 meters. Then, what are we going to know if G to K is 6 meters? H to J is 6 meters. Good. How did you know it's going to be H to J? Good. Opposite sides. So opposite sides are congruent. Good. Whoops. We need one more point here. Sorry. The point where the diagonals bisect, we need a point there. Just add that in. We're going to make that an M. Alright. Okay, for our next sentence starter, if HK equals 26 miles, then MJ equals what?
How do we go from meters to miles?
We're just doing like 2 different problems. These are separate. Sorry. We're just changing it as we go. We're not keeping one exact. It's just a diagram. The diagram's changing. Does that make sense? 13?
Yeah.
How'd you get 13?
It's don't say till I make that. It's not made up.
It's in the middle.
It's in the middle, yeah. And H to K is 26. So how did you know that M to J would be 13? Because that's not part of H to K. Yeah, G to J, these are congruent. So the whole thing here is 26. And then M is in the middle. It bisects it. It's the midpoint. So if we do 26 divided by 2, (26) divided by 2 is 13. There's a lot going on out there. It's not hard to focus sometimes. I got so distracted there. Alright, next up we got if the measure of angle, so now we're going to look at an angle, JKH equals 27 degrees. Then the measure of angle KGM equals, and we're going to have to find that out. So when we do this problem, what are we going to start by doing? Before I even really think about the math or the 27, what do we have to figure out? I saw someone using kind of their finger. I'm seeing a lot of you looking at the picture. What are you trying to find? Okay, maybe I'm asking too simple of a question. We just have to find where the angles are, right? So where is JKH? If I look for JKH, J to K to H, so that's this bottom angle here. So we're saying that that angle is 27 degrees. We know that. But now if I look for KGM, yep, KGM, that's this one here. So how am I going to go from one corner to the other corner? Because those angles aren't really next to each other. So how can I think of, how am I going to jump from this green angle up to that blue angle? What's the same? The green and blue are the same?
No.
Are they? Are these ones the same? No, you have the right idea though of thinking the same. Remember, back up to our picture here. What is the same as this green angle? Where else could I put that congruent mark? I could do KJM. But if I want to go up to this blue angle, I could do HGM. This angle here. So I know that these two are the same. So I'm going to write that real quick down here. I'm going to kind of show that angle. So if I have that angle there, which one is 27 degrees? Kind of the bottom one or the top one? The topish one. This one's 27 degrees. How am I going to find the bottom angle there? I know it's a rectangle. What do we know that total angle has to be? 90, because they're all 90-degree angles, right? This is just a struggle today with this. There we go. Okay, it has to be a 90-degree angle, because they have 90-degree corners. So we're going to think, what is 90 minus 27? 83. 63. So KGM is going to be 63 degrees. All right, last problem, number 2. Number 2, we're going to just draw a nice rectangle. Doesn't need diagonals. In fact, we're not even going to label it because we're going to be terrible people and not label. I make all my rectangles look the same. I never make it like the other way where it's like tall and lean. I always go wide. I don't know. That's the way my life is. All right, this top angle, or this top side is going to be 3x plus 6 and the bottom one is going to be 7x minus, no, what was it? 1 second. That doesn't make sense. Yeah, minus 6. right? Yeah. And our directions are going to be to find x. So how are we going to set up an equation here to find x? What do we know about those sides? Here, a quiet class today. What do we know about the top side and the bottom side? Yeah, they're congruent. They're the same. If they're congruent, that means that they are equal. So we're going to write our equation. We're going to say 3x plus 6 equals, what's the other side? 7x minus 6. And then we're going to solve that equation. What's different about this equation compared to the ones you did in the warm-up? Or what do you see that sticks out to you? Yeah, there's x's on both sides, so we have to get them on the same side. So do you guys want to get rid of the 3x or get rid of the 7x? Yeah, I always like to get rid of that one too. How would we undo adding 7? What? What did you say? Yeah. Subtract 7x. And if we do it on one side, we're going to do it on other side. On the other side, we do it right underneath that 3x. So 3 minus 7, negative 4, x plus 6 equals, what am I left with on the right side? Negative 6. Good. All right, then what? Minus 6 on both sides. So negative 4x equals negative 12. And then lastly, divide. So x equals what? Negative? Beautiful.